Hey guys, so SimpleTuner just dropped FLUX support, and so did ComfyUI. So now we can load LoRAs into ComfyUI for FLUX, and today I'm going to show you how to actually train one with SimpleTuner. So let's get into it. Alright, to start off, you're actually going to want to prepare your dataset. For FLUX, you'll definitely need to crop your images from to square, from rectangular, or whatever they are. So I'm going to take in just a few of these images to show you how Caption Helper works. If you have text files that are associated with the image, it'll automatically pair them up. But if you don't, then you can use the interrogate features. So enter your API keys for Grok and OpenAI. Grok is for the enhance and extend, and then OpenAI is for the interrogate feature. And then I would definitely set your GPT options with your custom token, and then your custom instructions, as well as inherent attributes. So for this cat, the cat has gray patches, so we don't want to include those in the captions. But we can go ahead and just try interrogating an image for fun. And then, yep, so it looks pretty good. You can also enhance. So be careful with this, because if it is too long, the text encoder will cut off the rest of the caption. So I'm just going to undo that. So this kind of length is pretty good so far. And then, of course, you'll export it. If you, since we're going to be cropping the images, it defaults to square. You'll want to include these images in your export, and then I also like to rename the images sequentially. And I could just use any name, but I'll just use Albert. And then just make sure you double check your captions before you use them to make sure everything looks good. The next thing you'll want to do is upload your dataset to Hugging Face. So we'll just go to new dataset, and I'll just call this test for FLUX. And then usually I'll just make it public because it's easier that way to download it with Git. And then we can create the dataset. We'll go ahead and add our files. And we can just add all of those. This step is optional if you want to just download from a CDN or something and grab your images that way, or if you have some other multi-data backend set up for SimpleTuner. But this is just what I'm using so that it works with my JSON file. And then from this point out, we're pretty much just following the FLUX Quickstart guide from SimpleTuner. For the actual system requirements, you'll want to take a look here in the page linked in the README. It's quoting an A100 for rank 16 LoRA, but I think we can probably get away with a smaller rank and just use an A6000. Because if we go over here, RTX A6000 ADA is only 103 per hour. But if we wanted to go with an A100 PCIe, that'd be $1.69 an hour. So I'm just going to go with this one. And then we can go with, we'll have to edit the template because we'll need a little bit more storage to actually fit the FLUX model. And then we'll just use Jupyter Notebook because it's really the easiest way to use RunPod. And then we'll just go ahead and deploy on demand. And then once you're here, we can just go ahead and connect to this. We'll connect to Jupyter Lab. We'll open up a terminal. And then it's pretty much just up to following the instructions from the SimpleTuner repo. So I'm going to head back over there. And then we'll make sure that Python's installed. I'm pretty sure it comes installed on all of them. Yep. And then, let's see. So we'll go ahead and git clone SimpleTuner. And then we'll cd to SimpleTuner. We'll create our virtual environment. And then we'll activate our virtual environment. We'll go ahead and install Poetry. Get the next command ready. We're going to use this middle one, Poetry install no root. And this one takes a minute, so just maybe get a cup of coffee. Alright, now that that's done installing everything there, we'll go ahead and go back to this documentation. And for now, we have to use a custom diffusers build because it's not in the main diffusers branch. So we'll uninstall the diffusers that it already installed, and then we'll go ahead and grab this LoRA support FLUX branch. And that'll also take a little bit of time. This one, it did not like that. Let's see. It couldn't find that. So actually, the main branch of diffusers might be working, so let's take a look at that. Alright, so for now, what we're going to do is we're just going to install the main branch. So instead of diffusers at LoRA support FLUX, we're just going to do at main. And so this will just get the very latest version from the main branch of diffusers. And then, let's see, we're going to go ahead and get our configuration file copied over. So now we can go into our actual configuration documents, and then config.env. This is going to be basically your entire settings file. So we'll go through this one at a time. But first, what I want to do is take a look at the multi-data backend .json, because this is where you're actually going to put your data set. So I'm assuming that we're using the method of uploading it to a Hugging Face as a data set, and then we're just going to download it back as a Git repo with git lfs. So if we do a new file, we'll do multi-data backend, and because it's in a Jupyter notebook, I'm just going to keep it as txt for now, and I'm going to steal one of these from my older runs, so I'm just going to grab the raw, oops, we'll go ahead and just grab it like this, and then I'm going to change this to Albert. This is going to be all Albert, but this is basically all you need for the entire thing. We're keeping crop on true just because it doesn't have aspect ratio bucketing just yet. Even though we did crop our images already, it can give you some errors if you don't enable crop as true in the multi-data backend. So I'll go ahead and save that, and then I'm going to rename it to .json. And then just double check and make sure it's all here, yep. And then we can close out of all of those, and we can get back to our config.env. And so we have a lot of the documentation for this here. We're going to set the model type to LoRA, set flux to true, and then we're going to have to grab this model name. So this is pretty much the rest of it is going to stay default. So export model type is LoRA. Export flux is going to be true. And then you can use DORA apparently with Flux, but I have not tried it yet, so I guess your mileage may vary. For checkpointing steps, I'm actually going to do 100 because that's just a little bit nicer, and then I'll keep 3 checkpoints. For the learning rate, I'm actually going to export a new one. So I'm just going to grab this, and I'm just going to call this 1. Because we're actually going to be using Prodigy for the optimizer since we're using quantization for the model itself. We'll go back here, I'm going to copy this, and then I'll paste it here instead of SDXL base. And then I'm going to use, let's call this Albert Flux, and we'll call this run v1. Maximum training steps, I find that 2000 is pretty much the max I could get before it started to overtrain the model. But, you know, obviously your mileage will vary because of your dataset and all stuff like that. Because we're using the multi-data backend.json, we can just keep this to default, and output models is fine. I'm going to push all of my models to Hugging Face just because it's easier to download them since I have multiple machines. I'll keep push checkpoints as true. And then here we have all of our resolution settings. Resolution can stay the same as SDXL because we're just going to be using a 1 megapixel training resolution. And then let's see, for the actual validation prompts and everything, we're going to want to change this. So we'll change this to 3.5 for the scale, and then we'll do Albert the cat riding a horse on the moon. So this is a good prompt because it's not actually in our training data, so we're going to be testing the model's ability to generalize. Validation steps. There's actually a bug right now with validation steps. I'm setting it to 2000 so it doesn't validate at all until the very end. So actually 2001, just so that it doesn't try to validate, because we're getting some kind of error. But this very well might be fixed by the time you're watching this video, so you might not have to do that. Otherwise, I would just set it to 100 so that it does a validation image every time it checkpoints. For number of steps, it doesn't actually matter because we're not using that. For the batch size, I'm just going to set it to 1 and gradient accumulation steps to 1. This is to use the smallest amount of VRAM possible. However, I will say that it's going to learn a lot better if you use a batch size like maybe 4, or I've gotten up to 16 on an A100, and it used pretty much all the VRAM, but it did get away with it. And it trains a lot slower, so just be mindful of that. So these are our hyperparameters that kind of go beyond the scope of this tutorial, because it's kind of a machine learning concept and less of a SimpleTuner concept. I'm going to set this to cosine. Actually, sine is probably fine. And then for warm-up steps, we're going to use this calculation of the warm-up steps instead of just 1,000. For all of the workers we can keep pretty much all the same. I'm not going to delete any of the errored images or small images because that can damage your data set. It just makes it a pain in the ass to go back and fix anything that it does because you don't know which files it's gotten rid of. And then we're actually going to have to disable transformers because it doesn't support it right now, so set transformers to false, and then we'll go back into here and we'll do pip uninstall transformers. And then yes, there we go. And then gradient checkpointing is true. We will have to change the optimizer because AtomW BF16 is not going to work while we're quantizing the model, so I'm going to use Prodigy. You could also use Eta Factor, but then you'd have to actually set the learning rate. I'm terrible at figuring out learning rates because, I don't know, it's just kind of a difficult concept. But Prodigy just kind of takes care of that by itself, so that should be fine. And then trainer extra args, I don't think we need anything other than just for quantization, so if we go back into the documentation, we can go ahead and pip install optimum quanto, and then if we go back into our env file, we can go ahead and set base model precision to int8 quanto. That sounds very funny. But export extra trainer extra args. And then also you can go ahead and change, any of these if you want to. And then obviously this is just talking about the different optimizer. But I think that should be it for actually setting up the actual config.env file. I'm going to go ahead and save that. And then it's kind of doing its own thing over here, uninstalling Torch. So that's going to take a hot minute. And using quantization, it just does take longer in general because it has to freeze the whole model before it starts. So just expect that you're going to be taking a little bit extra time. And then this is basically just telling us that our version of Torch Vision is not compatible. So we'll do pip install upgrade Torch Vision. Alright, that should take care of that. And then I'm just going to make sure that Transformers is still uninstalled. Okay, yeah, still not there. Alright, next up is we're going to get our actual data set up in our repository. So it has the multi-data backend.json for this pseudo camera 10K, but pretty much all we have to do is go ahead and we're going to do apt get upgrade, update. And then we're going to apt-y install git lfs. We're going to make a datasets directory. We're going to just pop into that datasets directory. We're going to git clone, and then we can go ahead and find our actual dataset. So I'm just going to copy the link for that. Git clone, and we'll do this test for FLUX. Okay, and then we can, let's see, we can just pop out of that directory. And now if we go into datasets, test for FLUX, we'll just go ahead and make sure that our pictures are actually working. It is. And then I named it Albert in our multi-data backend, so I'm just going to call this Albert. And then, let's see, for Hugging Face, you'll need to do Hugging Face CLI login. So I'm going to do that real quick. Let me grab a token. And then if you want to log into WanDB, what you'd have to do is you'd have to go into the extra model arguments. So let's see where the args were. And you could either use TensorBoard or WanDB. So WanDB is fine, but I'm actually just gonna comment that out so we don't report to anything for this one. You really should, just so that you can actually track the loss. That's kind of the whole point of using SimpleTuner. But if you don't want to look at any of that, if you just want to raw dog it, you could just comment that out. That's fine. We'll go back in here, and then the very last thing to do is bash train.sh. So I'm gonna go ahead and enter that. And then we're going to see what error it gives us, because from my experience, it's never worked on the first try. And right after you send the command, it's going to take a hot minute. It's going to download all of the models, the tokenizer is going to load everything up. Okay, and here's where it's gone pretty far. It's loading Quanto for LoRA training, and this is actually going to take a few minutes. But getting this far is actually really good. Usually doesn't get this far on the first go. I guess we did everything right this time. Alright, as you can see, it did truncate one of my prompts, because it can only handle up to 77 tokens using clip L. But it just bed in furniture, so it's not really that big of a deal. But let's see. I'm just going to not visualize my results for WanDB. And now it's actually getting into the training, which is really exciting because it's only quoting about 2 hours, where we're getting about 3.5 seconds per iteration. So that's like really, really good. Keep in mind though that this is batch size 1, so your training is going to be a lot slower than this. But yeah, let's go ahead and we're going to wait for it to checkpoint at the first 100 steps, and then we'll go ahead and see if the LoRA is actually going to load. Alright, so it looks like our training did come to a halt after 100 steps. It tried to save the checkpoint, but it did not go through. So luckily this just looks like something wrong with the dependencies, so I'm just going to go ahead and reinstall or upgrade these towards deep speed and accelerate, see if that helps. And then I'm going to go ahead and go back into our arguments, and I'm going to look for our steps. Our checkpointing steps, and I'm just going to set that to 10, and then it'll checkpoint every 10. So let's go ahead and bash train.sh, and then we're going to have to wait for all of this to load up again. Okay, once again, it ran into an error. This is going to be a common theme of like having to restart the training, but here all we have to do is go into our output. It just thinks that there is a checkpoint here because there's a folder, so we're going to delete this. Ooh, not duplicate. Let's see, go ahead and delete those, just because you can't delete a folder in Jupyter if it has stuff in it. So we'll get rid of that. So now there shouldn't be an issue. We should be able to go ahead and train again. Okay, here we go again. Let's just bypass 1dB. Okay, so it was able to successfully save the checkpoint at 10 steps. So I'm going to go ahead and stop this training. And we can go ahead and go back to checkpointing steps 100. So that was just so that I could test out to make sure that it was working and I wouldn't have to wait for it to go through 100 steps. But if we go into our models folder, if you had validation images, if you're using those, again, we're not using those because of the bug earlier. If you have those, they would be in this folder, but here we'll just go into our checkpoint. And then what you're looking for is the PyTorch LoRA weights.safetensors, so this file. So you can go ahead and just download that directly, and you can load that up into ComfyUI, or you can wait for it to upload all of the checkpoints into Hugging Face, and you can download it from there. But that is pretty much it for actually training the LoRA. Let's go ahead and test. We're going to just do the manual validation real quick. Alright, the model is about half done training, about 1,000 steps. I think it might start degrading the quality of the outputs around now, but I'm not sure it's actually trained the actual character of Albert yet. So it's kind of a balancing act. You'll definitely have to play around with the hyperparameters. But this is all loaded up, and because we set that we're pushing the Hugging Face, I can actually go over here, and if we go over to the files, we can see we're at 1,000 steps, so we can just download the PyTorch LoRA weights and load that into ComfyUI. If you don't want to load it into ComfyUI to validate, what you can do is you can just copy this address and make sure it's public, and then we can go to this Hugging Face space I just spun up, and you can paste in your LoRA ID. As long as it has the PyTorch model weights.safetensors file in that space, it'll use that LoRA. So we could say like a photo of Albert the cat. And then again, I doubt it's actually going to produce anything that resembles the cat that we're trying to train on, just because it definitely hasn't learned it yet, but we'll see. Okay, that's actually a little bit horrifying, but let's try it in ComfyUI because I have a feeling it's going to work a little bit better. So here I actually have a ComfyUI workflow with the LoRA node already added, so I'm just going to load that into ComfyUI. And then I have the 800 step version of the LoRA loaded, and a pretty basic prompt. You can see I've already run it a few times. It doesn't look anything like the cat, but at least it's definitely not the nightmare fuel that we were seeing earlier. So if we go ahead and queue that prompt, we can see what's going on with the model. Okay, it's definitely not Albert, and the whole image kind of has this like washed out, like almost vintage kind of a look. That just is an artifact of we've kind of trained it a little bit too much. But it's weird that it hasn't learned the concept. None of the LoRAs that I've trained so far have actually learned the concept that well, so I'm starting to think there might be some kind of technical limitation with this, but I'm hoping that with this video going out, you guys will be able to train some LoRAs and maybe give some insight into what the best parameters might be, because like, I'm not personally just having luck, but I'm not a great LoRA trainer in general. I wasn't great at training LoRAs with stable diffusion, so I guess take this with a grain of salt. But I would definitely encourage you to give it a try. It's not terribly difficult once you get over the learning curve of using SimpleTuner through that like command line interface. But yeah. Anyway, I hope this video helped you at least a little bit. I'm really curious to see what you guys create with FLUX, because it's a really great model. I just wish it was better for fine-tuning. But yeah, have a great day, guys.